All right, guys. So we had started looking at decimal from the previous class, right? Is that so? Everybody recall that?
Yes, sir.
Yes, sir.
Right. And so we say decimal would be special types of fractions, and of such, they would fall in the set of rationals. And we learned something about decimal last week. Can anybody just give me a quick recap of what you have learned? Starting with you, Miss Wilson, what have you learned about decimal? All right, I'm not getting a response from Miss Wilson. Mr. Campbell, would you like to jump right in and tell us what you have learned?
Can you help me?
Yes, sir.
Okay, go ahead, Mr. Campbell.
All right, sorry about that. I learned that decimals can be added, subtracted, multiplied, and divided. Or something, right?
All right, thanks for your input. Anybody else would like to add to that? iPhone person, can you identify yourself for me, please? Person with the iPhone, can you just identify yourself?
Hi, Chair.
Oh, hi. Good evening, sir. All right. Mr. Giovanni?
Yes, sir.
Were you here the last class?
Yes, sir.
All right. So give me a little reflection of what you have learned from the last class.
We learned about multiplying decimal numbers.
Okay. All right. Just let me recap what we have gone through. It seems as if what we have gone through have not yet cemented into the minds of persons. Just be reminded that the notes are on the website. So you can go to the website, click on September to December notes, and you should see a list of notes there, and you should see decimal somewhere there. You can actually click on it, and across from the on the right hand side, you should see where you have worksheet 2 as well. All right, so I'm expecting you guys to take a little time out, try and look at the notes before you come to the class. So if you spend at least half an hour just reading something before you come to the class, it will benefit you tremendously. All right, guys? So I'm expecting you to do that. All right, so we say decimal has to do with 10. So when we are looking at decimal, we are looking at a special type of fraction. And if it's a fraction, we expect it to be similar to fraction in that you may have a fractional part, you may have a whole number part, and you may have a mixture of whole number with fraction. All right, now we would have looked at this number, 666. In terms of the place value, we see that to the right, the first 6 would be in the ones column, the second one would be in the tens column, and third one would be the hundreds column. What it really means is that when you write 666, it means that you're adding 600 plus 60 plus 6. All right, so that is in terms of place values. Now, if you look at what is happening, you add 6, then 60, then 600. You notice that in the tens column, you have a 0. In the hundreds column, you have 2 zeros. In the ones column, however, you don't have a 0. And there's a reason why we don't have a 0 there. Can anybody tell us why we don't have a 0 in the ones column?
Because 6 is a counting number.
Well, if
A single digit.
If we are thinking of the place value in terms of powers of 10, then the ones column, so you have the ones column, you have the tens column, and then you have the hundreds column. But the ones column in terms of power of 10, it would be 10 to the, what power would this register?
0 power.
10 to the 0 power, right. And because anybody know anything about raising any number to 0? The second column, which is the 10 column, would be 10 to the 1. The third column would be 10 to the 2, right? Anybody know anything about raising a number to 0 power? What do we get when you raise a number to 0 power? Anybody?
Same number, sir.
Same number.
Well, not just the same number. You get any number raised to the power 0 would be 1. So really, in essence, then, when you're really writing these 666, what it really means, it means 6 times 10 to the power 2 plus 6 times 10 to the power 1 plus 6 times 10 to the power 0. That's what it's actually saying, you know. Now, 10 squared would be what? 10 to the power 2 what?
100, sir.
Right, so this would be 6 times 100. And the other one would be just 6 times 10. And the final one would be 6 times what? The other one would be what? 6 times what?
1.
6 times 1.
1.
All right, because any number raised to the power 0 gives you 1. Now, one of the things you can notice though, is that the number of zeros here is a direct reflection of the powers. So where you have the power 0, then you just only have a 1 with no 0 beside it. Where you have 10 to the power 1, you have 1 0 beside it. Where you have 10 to the power 2, which is 100, you have 2 zeros beside it. So the power actually tell you how many zeros in the powers of 10. And so for the first digit, there's no 0 in the powers of 10 here. So if you raise power of 10 to the 0, you're just going to get 1. And so that's why we have that as the unit column, because it will always be multiplied by 10 to the 0 power, which is whatever number times 1. All right, is that clear to you guys? All right.
Yes, sir.
So here we say decimals are fractions with denominators of the base 10 raised to some power. And I would have gone through and explaining to you that the whole number section would be actually, let me clear this. All right, so the whole number section would be before the decimal point, and the fractional section comes after the decimal point. So these numbers that comes after the decimal point, they are pretty much fraction where the denominator is some powers of 10. Now the first digit after the point is over 10 to the 1. So in other words, you only have 1 0 down. If you have the second number after the point, then you're going to have 2 0 down. So the amount of numbers that come after the point will determine how many zeros in the denominators. So if you have 3 digits after the point, the denominator is going to take 3 zeros. That means this would be 10 to the power 3, this would be 10 to the power 2, and this would be 10 to the power 1. So that's how we actually note the fractional parts of these numbers. So if you just only have one number after the point, then it must be over 10 to the power 1. If you have two numbers over 10 to the power 2, so it means that the 3 and the 0, well, the 0 itself is in terms of the place value. It comes after the first digit. So it means that it will be 10 to the power 2. So by counting these digits, you know how many zeros you have down here. So the third digit, which is 5, must be over 10 to the, over 3 zeros. So in other words, if you count 1, 2, 3 digits, then you count 1, 2, 3 zeros. All right, so that would give you the fractional part of decimals. Now, what you notice about the powers of 10 in the fractional part, you would notice that they are the denominators, right? And that is why we really call it decimal, because the denominator is in powers of 10. All right, now, so the denominators of the fractional part going to be in some powers of 10, and all the digits that come after the points, those are going to be in the fractional part. That means they're going to be over either 10, over 100, over 1,000, or 10,000, etc. Now, the digits that come before the decimal point, those are whole numbers. And so whole numbers are not being divided by the powers of 10, but instead they are being multiplied by powers of 10. Just as how I showed you in the example of the 666 just now, where the first one would be 6 times 10 to the power 1, sorry, 6 times 10 to the power 0, then 6 times 10 to the power 2, then 6 times 10 to the power 3, and so on. All right, so when you look at this whole number, this is how we would write them. So it will be 200 times, sorry, 2 times 100, because this is in what? This would be in the place value of the 100. This would be in the place value of the 10. And the 4 would be in the place value of the 1. So instead of having them as denominators, now we're multiplying by them. So multiplying by the powers of 10. So that is how we distinguish the digits that come before the point. These are in-place values of powers of 10. Is that clear to everybody? Any questions so far, guys? Is it clear? Let me see the hands of those who are understanding so far. All right. Okay. So what we would have learned from this is that decimals are actually special fractions. You have a whole number part and you have a fractional part. So here we would have 4.67. The whole number part is the 4, and the number that comes before the point would be the whole number part. And the numbers that come after the point, those would be the fractional parts. So if we are going to consider the 4, then this would be 4 in the ones column. And this now would be the fractional part. So the first digit will be out of 10, second one will be out of 100, or you can just simply write the 2 digits together over 100. So this would be equal to whole number part, which is 4, fractional part, which is 6.67. We would write that now as 67 over 100. And this is how we actually go about converting our decimals to fraction. Any question? Is it clear, guys? Raise your hand. Let me get your response. All right, now I am going to ask of you if there's anything that you're not sure about, you should ask a question so that you get clarification. Because what I don't want to be moving ahead without you guys getting clearly what I'm saying. All right, Mr. Reed, you can lower your hand. All right, so we get the hang of what a decimal is. So you have a whole number part and you have the fractional part. Now, the whole number part and the fractional parts are separated by a point known as the decimal point. Now, there are times when we don't have any whole number part. So if there's no whole number part, we always insert a 0 in front of the point, all right? So we put a 0 in front of the point. All right, so we had looked at addition and subtraction of decimal, and we clearly have rules when we're adding decimal, adding and subtracting decimal. Anybody want to recap the rules? How do we add decimals? Let me call on some persons. Miss Green, how do we add decimals? Are you hearing me, Miss Green? All right, I'm not getting any response. Go ahead, Mr. Campbell.
Addition, adding and subtracting decimals. It's basically like 4 numbers.
Okay, so what is the rule though?
the decimal point beneath the other one, vertical, beneath the other vertical.
Okay, so it is important that when we're adding, we generally line up the decimal point one beneath the other in a straight line so that we will be able to add the appropriate values, all right? So adding or subtracting decimal is done exactly the same way as whole number. Rule, place the decimal point in vertical lines one beneath the other. So having done that, you can just add in the usual way. So here we have 3 values and we are to add them. Now, if you have a whole number, remember that after the whole number would come what? A decimal point. So if you are setting them out, you would put them point under point. And here where you have the whole number 12. All right, so it's probably easier for me to write it down and show you what's happening. So we write down the 0.539. And then we write down the 9, and so we are putting point under point, 9.65. And then now we would have 12. Which side of the decimal point would that goes? Where would we put it? We would have to put it with
Whole number side, sir.
right.
The whole number side.
So it has to be in front of the decimal. So here now we would have the 2 lining up with the 1's column, and this one would now be in a 10th column. Now, once we align the points up on the point, what we'll notice is that there will be some spaces where you don't have any number. And so in that case, if you find that you have some empty spaces, we are going to fill them in with zeros. Let me use a different color. So here we would fill in here with 0. We'll fill in these 3 places down here with 0. Up here we fill here with 0. And we'll also fill in this section with 0. And so after we fill in all the empty spaces now, we would just add in the usual way as how we add the whole numbers. So we add 9 plus 0, give you back 9. And 5 plus 3 plus 0 will give you 8. And 5 plus 6 plus 0 give you 11. Now you put down 1 and you carry 1 over here. Or remember now, you have to put your decimal point here because we are following the whole one beneath the other. So once you're moving from the last digit after the point, then if you're carrying any number at all, you're going to carry it to the 1's column. So now we have 1 plus 9 give you 10 plus 2. We put down 2, carry 1. Over here now we have 1 plus 0 plus 0 plus 1. So our answer would be 2. All right? And that's how it is done, guys. Now, the same rule will apply if you're subtracting. And if you're subtracting, you're generally going to have one number subtracting another. So you're still going to line it up and put point on the point. Is that clear, guys? Can I move on now? Raise your hand. All right, so as I was saying now, so we would just put them in like that. then we add, you get 22.18. All right, so that is for the rule of adding and subtracting. Now, multiplying and dividing decimals. We looked at how decimals can be multiplied by powers of 10 very easily, because when we're multiplying by any powers of 10, we actually move the decimal point based on the number of zeros in the power of 10. So if we have 1 0, then we move 1 0 to the right. So we move the decimal point 1 place to the right. So if you have 1 0 in the power of 10, you move it 1 place to the right. You have 2 zeros in the power of 10, 2 places to the right, and so on. That is when you're multiplying by powers of 10. So it means that to multiply any decimal, it's very easy when you're multiplying it by any of these numbers, 10, 100, 1,000, 10,000. So if you have 0. Let me use that different. So if we have 0.023. Now, if we times this by 10, what would this become? Calling upon some people now. Miss Clark, what would this become? Are you there, Miss Clark? Are you hearing me? I'd like that you respond. Can you raise your hand, Miss Clark, if you are hearing me? All right, go ahead, Miss Shea. What would be the answer?
Sir, the answer would be 0.23.
0.23. All right, anybody else agree with Miss?
Yes, sir.
Right. Anybody else? Miss Cummins, very good.
Yes, sir.
All right, so based on what I've said, if you're multiplying by a power of 10, now this power of 10 would be just 10 to the power 1. So that means you only have 1 0 in this. So if you're multiplying a decimal where the power of 10 only have 1 0, that means you're going to move the point 1 place to the right. And once you have done that, now we will get 0.23. All right, so that should be pretty straightforward for everybody. Now, if we multiply the same number, instead now by 1,000, what would we get? And bear in mind, guys, when the Zoom runs out, you just log back in, all right? What would be the answer to this one now?
23.
Let me ask somebody who is not saying anything. All right. Miss Clark, are you there? Miss Clark, are you there? Trivia, are you there? Guys, this is an interactive class and we need your participation, all right? Everybody will partake in the exercise. All right, I don't want the same person to be answering all the time. Mr. Reed.
Sir.
Yes, go ahead.
0.2 0.023.
The answer would be 0.0.
023.
Let me write what you said. 0.
Point
0 2 3.
23.
That's what you said. All right. Anybody else agree with Mr. Reed?
So since it's multiplied by 1,000, wouldn't it be wouldn't the answer be 23?
Yes, sir. That's what I got as well.
Okay. Mr. Reed, do you see what is being said?
No.
All right. So we are saying that when we're multiplying by any powers of 10, we're going to move the point to the right based on how many zeros we have. So how many zeros we have in 1,000? Mr. Reed.
3, sir. 3.
And the point is here, and we're going to move it to the right. How many places?
3 places.
All right, so if we move 1, 2, 3, the point now will end up here. So it's going to be behind these numbers here. So if the point is behind these numbers, what numbers are to the left of the point? What are the numbers to the left of the point? Remember, I just said
whole number.
the whole numbers. So what number would be the number? You wouldn't put down 0, 2, 3. You would just put down what? 23. You see
23.
that? Right. So the answer would be 23. Is that clear now to you, Mr. Reed?
Yes, sir.
All right.
Yes, sir.
All right. Everybody is good with that? Let me see all the hands. All right. Now, on the other hand, if we are dividing 0.23, if we are dividing that now by 100, what will happen? What would be the answer?